Hello, my name's Jason Bruce and I'm from the University of Manchester in the UK. The title of my e-poster is Insulin Receptor Deletion in Pancreatic Acinar Cell leads to loss of antimicrobial secretion and impaired gut barrier function. Possible link between diabetes and severity of pancreatitis. So there's a strong link between pancreatitis and diabetes, not least because of the collateral beta cell injury that occurs during the acute phase of injury. But there's also evidence that diabetes can make pancreatitis more severe, but the evidence and the mechanism for this is poorly understood. What I hope to convince you is that insulin regulates the expression and secretion of registry beta from acinar cells into the gut, which maintains a healthy gut microbiome and barrier function. We postulate that during diabetes, there's a loss of registry beta secretion leading to dysbiosis and impaired gut barrier function, which then facilitates bacterial translocation and a more severe pancreatitis. These experiments were performed on Secretome mice in which the insulin receptor is specifically deleted within acinar cells of adult mice using a tamoxifen-induced Cre recombinase system. These mice are normoglycemic and are not diabetic, and the insulin receptor remains expressed in other tissues such as the spleen, the liver, the muscle, and the kidney. So registry beta has antimicrobial properties as shown by the E. coli growth plates. We can also detect registry beta within the supernatant or secretome of stimulated acinar cells. But the expression of registry beta is abolished and the secretion of registry beta is abolished in Secretome mice. If we take the secretome and add it to bacteria, we see a reduction in bacterial colony formation, which is abolished in the Secretome mice. So collectively, these data so far show that insulin regulates the expression and secretion of registry beta from the acinar cells into the gut, but this is abolished in the Secretome mice. So the big question really is, well, what's the gut phenotype of these Secretome mice? Well, the Secretome mice exhibit inflammation in both the small intestine and the colon, as detected by CD45. We also see a reduction in goblet cell number within the colon of Secretome mice, suggesting that there's an impaired mucus secretion. And the Secretome mouse colon exhibits bacterial colonization as detected by FISH, suggesting that there's an impaired barrier function in the colon of the Secretome mice. So, to summarize then, insulin regulates registry beta expression and secretion from acinar cells into the gut, which maintains a healthy gut microbiome. During diabetes, there's a loss of registry beta secretion leading to dysbiosis, inflammation, and bacterial translocation, which we believe contributes to the severity of pancreatitis. Thank you very much for your attention.